So in this session, we're just going to go through a step question, which hopefully you've seen before, and then perhaps we'll have some time at the end to answer questions. And if, of course, if you have any questions, just put them in the chat, and if they're relevant, we'll answer them immediately, and if not, we'll probably have time to go back to them. Okay, now I'm going to share my screen. And if you can see that, can you type in yes into the chat? Or no if you can't. Okay, I see lots of yeses. This is good. So this is a step 2 question from 2016, and it's question 2. And okay, so let's dive straight in and try and answer this question. Firstly, let's note that it's kind of a typical step question in that it's split into parts, but it has a part before the first part. And if you've been to Claire's workshop, then you'll know that this is called the stem of the question. So this is this bit here. And it's a really good idea to read the stem of the question carefully. Well, firstly, if it tells you to do something, you don't want to miss marks for like not reading the question properly. And secondly, the stem is there to help you, to be honest. It will probably contain lots of hints on how to do the first and second parts of the question. So definitely read the stem carefully. And in this question, the stem is use the factor theorem to show that a plus b minus c is a factor of thing, which is a long expression. Someone has admitted, okay, never mind, which is this expression called star, hence factorize star completely. Well, first it tells us to use the factor theorem, so it's probably a good idea to use the factor theorem. And can anyone tell me in the chat what the factor theorem is, if they know it?
I think it takes a while to type out the whole theorem.
Yes, I see lots of factors. So yeah, that's right. Well, the factor theorem, well, firstly, what is the factor theorem about? It's about polynomials. So if p of x is a polynomial, and remember that polynomials are things that look like a to the n, x to the n plus dot 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 plus a1 x plus a naught, then, well, if x minus a is a factor of p of x, then if we evaluate the polynomial a, we get 0. And it tells us a bit more. It tells us that conversely, if p of a equals 0, then x minus a is a factor of p of x. Okay, so now we want to use this to show that a plus b minus c is a factor of star. But the factor theorem is about polynomials, and this looks a bit nasty at the moment. It doesn't really look like a polynomial. So who has any ideas on how to relate this to polynomials? I guess it might be a bit long to write in the chat, so we'll give it a second. Think about like what would the variable be? So before we had a polynomial on x, That's a good idea. So somebody said, what if we make it a cubic in a plus b plus c? But we have terms that don't look like multiples of a plus b plus c, like a squared plus b squared plus c squared. So that might be a bit nasty. What about making your x? Somebody said make your x a minus c. I'm going to make it a c just to make it easier. So I'm going to consider star to be a polynomial in C with coefficients in A and B. Now, if the notation is confusing, just ignore it. What this means is that this is like stuff times C cubed. If we expand all of this out, we'll get stuff times C cubed plus stuff times C squared plus stuff times C plus stuff. And these are going to depend on A and B. So now we have a polynomial in C, and we want to show that a plus b minus c is a factor of star, is a factor of this polynomial. And Richard has asked, can you choose any letter to be the subject? Of course you can. You could easily have chosen A or B or C. I only chose C because C looks kind of special in a plus b minus c. And if you want to show that a plus b minus c is a factor of star, that's the same as showing that c minus a plus b is a factor of star. And well, that's precisely how we use the factor theorem, right? So by the factor theorem, c minus a plus b is a factor of our polynomial star if, and can someone quickly tell me what I want to evaluate at? Yeah, I see lots of a plus b's. Okay, so all that remains is now to just do this. This might be a bit tedious to watch, but here goes. So I'm going to put a plus b instead of the c here, and then a plus b, and then you have an a squared plus b squared plus a plus b squared plus 8a cubed plus b cubed plus a plus b cubed. Now I'm going to expand this out. Well, firstly, this is simplifying a bit. This is a 2a plus b. So this is an 8a plus b cubed. If I get wrong anywhere, somebody tell me quickly in the chat. Otherwise, it's going to be quite painful. So this is a 12a plus b at the front. And then you have, what is this? You have an a cubed plus b cubed, nope, an a squared plus b squared. There's two of them here, and then there's a 2ab plus 8, 2a cubed plus, well, I think I'm actually going to leave that as an a cubed plus b cubed plus 8a plus b cubed. Now the reason I've done this is because then I can stick together. We have a 16, a plus b cubed minus, there are probably better ways I could have done this, but okay, let's keep going. 12a plus b actually, I'm just going to leave this as an a plus b plus a squared plus b squared plus 8a cubed plus b cubed. And then the reason I've done this is because then I have a plus b cubed and then a 12a plus b a squared plus b squared plus 8, a cubed plus b cubed. Hopefully that makes sense. That was a bit of a roundabout way to do it, but yes. And then we have a 16 minus a 12, a plus b cubed, so that's a 4a plus b cubed. And then this is 8, well, I'll pull out a 4. 2a cubed plus 2b cubed. And then what is this? This is 3. Is there a minus? There is a minus sign missing here. There is a minus 3, a cubed minus, that's a 3 ab squared minus 3 a squared b minus 3b cubed. This is looking nice. This looks like a 4ab cubed, and then pull out a minus sign and you get a 4a cubed, because that's a 2 minus a 3. It's a minus 1, but we pulled out a minus sign, plus 3a squared b plus 3ba squared plus b cubed. And hopefully, can anyone tell me how to factorize this bit here? Yeah, great. So if you can recognize your coefficients here, that's a 1, 3, 3, 1. And if you know your binomial coefficients, which is, it's always good to know them, this is a plus b cubed here. And so great, we have a 4a plus b cubed minus a 4a plus b cubed, which is 0 as we wanted. So this is 0, and therefore, oops, I've run out of space. A plus b minus c is a factor of star. I think the details of the algebra aren't really too important. So if you didn't follow that, that's okay. You can come back to it and try it yourself. I think algebra is always easier to do yourself than to follow other people doing it. So yeah, okay, so back to the question. We have used the factor theorem to show that a plus b minus c is a factor of star. And then what we want to do now is hence factorize star completely. Now, this takes a bit of a trick. This is a bit of a hard question because it's not very specific, but can anyone tell me what's special about C in star? Yeah, so Eleanor has said that symmetric in terms, so star is symmetric in terms of A, B, and C, so C has little importance, and that's exactly right. We can replace C with A, or like swap round A, B, and C in any way, and you would get exactly the same expression of star. And so what that tells us is we can use exactly the same argument to show that, in fact, B plus C minus A is a factor of star. And what's the other one? I think it's A plus C minus B is a factor of star. But anyway, you can swap all of them around and it wouldn't make a difference. I'm going to write that down. So star is symmetric in A, B, C. So what do we have? A plus C minus B and B plus C minus A are also factors of star. And if we look at these factors that we have, so we have A plus B minus C, we have A plus C minus B, and we have B plus C minus A. Well, they're not multiples of each other, and they're all factors of star. So that means their product is a factor of star. Now, can someone tell me something about the degrees of star and this expression here? I'm seeing lots of threes in the chat, which is good. So yeah, exactly. If we consider star to be, say, a cubic in C, this is a degree 3 polynomial in C, and this thing here is also a degree 3 polynomial in C. And similarly, if we consider it as a degree 3 polynomial in A, they're both, if we consider them as polynomials in A, they're both degree 3. And so that tells us that they can only differ by a constant multiple. So star is equal to k times a plus b minus c, a plus c minus b, b plus c minus a. K is a constant. Now, how are we going to fix this constant? Yep, precisely. So we're going to consider the coefficient of a cubed. So in star, what is the coefficient of a cubed? Well, we have 1a cubed here, we have a minus 6a cubed here, and we have an 8a cubed here. So 1 minus 6 plus 8 is probably 3. And then what is the coefficient of a cubed in this red thing here? Yep, minus 1. I'm going to call this dagger. In dagger is minus 1, and therefore k. What is k? Great. K is minus 3, because that's what we need to multiply to get the coefficient of a cubed to match on both sides. So yeah, that is the first part of the question. It's a bit of algebra, but I think if you do lots of stat questions, you get used to the algebra. So don't be scared of the algebra at this stage. And you can see that we've used the factor theorem, which hopefully you will have seen before, or if not, you'll probably see in the future, which is, nice A-level topic, to apply it to something that we probably haven't seen before, which is factorizing a nasty-looking multivariate thing called star. Now, the next part of the question is to apply this to an actual polynomial. So we have used the result above to solve the equation x plus 1 cubed minus 3x plus 1 times 2x squared plus 5 plus 2 times 4x cubed plus 13 equals 0. It would be really nice if we could factorize this, because then the answer would be you just look at what the factors are. And so probably we're going to use the result above, which I have written down again here. And now I'm going to clean this up a bit. So I see that this is a 3 and this is a 2. But over here, this is a 6 and this is an 8. So in order to make this thing here look like this, I am going to pull out a factor of 2 here and a factor of 4 here. So that looks like x plus 1 cubed minus 6, x plus 1 x squared plus 5 over 2 plus 8 x cubed plus 13 over 4. And if we want to make this thing here into this thing here, we want to choose our A, B, and C so they look the same. Well, the first obvious thing to do is what am I going to set to x? Yeah. So I'm going to set x equals a. And And then what do we have left? We have b plus c equals 1. And then we have b squared plus c squared is equal to 5 over 2. And we have b cubed plus c cubed is equal to 13 over 4. Now we just need to solve this. This is, well, it looks like some cubics here, but actually we don't need this part. We're going to use the fact that c equals 1 minus b, substitute it in, you get c squared plus 1 minus b squared is equal to 5 over 2. And what is this? This is 2b squared minus 2b plus 1 is equal to 5 over 2. So that's 4b squared minus 4b plus 2 is equal to 5. So 4b squared minus 4b minus 3 equals 0. Factorize this. That's probably something like this. Let's guess a minus 3 and a plus 1. Does that work? We have a minus 6 here, we have a plus 2 here, and minus 6 plus 2 is minus 4. So yes, thank you from M. And so b equals minus a half, or b equals 3 over 2. And in this case, c equals 3 over 2, and c equals minus a half. And note that, well, we have essentially the same answer, except that b and c are swapped around. And this is what we expect, right? Because it's symmetric in b and c. And then finally, we should probably check that, let's choose, first of all, let's choose this one. Yes, we have a comment that we could have chosen x to be c or x to be b, and it wouldn't matter because it's symmetric in a, b, and c. So yeah, let's choose b equals minus a half and c equals 3 over 2, and we can check that minus half to the cubed plus 3 over 2 cubed is equal to minus 1 plus 27 over 8, which is equal to 26 over 8, which is equal to 13 over 4. Great. And then we can use what we have here to factorize what we have here. So we know that I've called this thing dagger. Well, I'm going to call the left-hand side of this equation dagger. And we know dagger is equal to, haven't quite left myself enough space for this, but this is going to be minus 3. We said that a is equal to x. We said b is equal to minus a half, and c is equal to 3 over 2. So that's minus a half minus 3 over 2. And then what do we have? My chat box is currently covering it up. Okay. We have x plus 3 over 2 minus plus. Minus is a plus a half. Then we have minus a half plus 3 over 2 minus x. I'm sorry, you probably can't see that. Hopefully you can now. And this is minus 3, x minus 2, x plus 2, and then 1 plus x. And so what is x? Yep, 2 minus 2 and 1. Minus 1. Should that be a minus 1? Yes. Good point. That's a 1 minus x. And so this should be a 1. I know this because I have done this question and hopefully it was right the first time. But anyway, so x is equal to 2 minus 2, 1. And that's the first part of the question. And if you have any questions so far, please put them in the chat. But if not, we'll move on. And so the second part is setting d plus e equals c or otherwise, show that a plus b minus d minus e is a factor of this even longer expression, which I have labeled star star. how long should you spend in deciding which questions you should attempt? I will, because it's not related to this question, I will leave it to the end, and hopefully we'll have time to answer that if Xander could note it down. But anyway, returning to this part, but it tells us to set d plus c equals c, so we should probably set d plus c equals c. And then what do we get? We have star star setting d plus c equals c. We have a plus b plus c cubed minus 6a plus b plus c plus a squared plus b squared plus, okay, this almost looks like c squared. So we have d squared plus e squared, but this isn't c squared. I think your teachers will get very angry at you if you say that this is c squared. So what is this? Yeah, so this is c squared. So this is d plus e squared, but then d plus e squared is d squared plus e squared plus 2de. Don't forget the cross terms. But so in order to get d squared plus e squared, we need to subtract 2de. And then plus 8a cubed plus b cubed. And then what is d cubed plus e cubed? Who can tell me? Great, it's c cubed minus 3d e squared minus, move my chat box, minus 3 e squared d. Yes. Now this almost looks like what we had before, except it's got some awkward terms that we didn't have before floating around, namely this bit and this bit. Now I'm going to shove everything that looks nice to the left and see what remains. Housekeeping. So this is a plus b plus c cubed minus 6a plus b plus c, a squared plus b squared plus c squared. And then we're going to leave this out for a bit, plus 8, a cubed plus b cubed plus c cubed. Then we have what we get a plus 12 de, a plus b plus c. And then from here we get a plus 8 times 3 is minus 24. So we get a minus 24 de squared plus e squared d. And then, well, what do we know about a plus b minus c in this bit here? From the first bit? Yes. In the very first part of the question, we showed that a plus b minus c is a factor of the bit that's circled here. And so all we need to do now is to show that a plus b minus c is a factor of this bit here. And well, what is this? This is 12 de, a plus b plus c. And then we have, because I pulled out a 12 de, that would be a minus 2 d plus e. And well, what is c? That's a d plus e, and minus 2 d plus e is a minus d minus e. And so this is equal to 12 de, a plus b minus d minus e. And so yeah, this we have a plus b minus d minus e is a factor of the blue thing from the first part. And we also know that a plus b minus d minus c is a factor of the green part just by factorizing it. And therefore, a plus b minus d minus e is a factor of the whole thing. Now, looking at star star and remembering what we did for the first part, can anyone tell me what some other factors are? we have permutations, which sounds right. Yes. So star is symmetric in A, B, D, and E again. So we can sort of swap the letters around, and we can use exactly the same argument to show that once we swap the letters around, that swapped thing is still a factor of star. And so Richard has suggested D plus E minus A plus A minus B. I'm probably going to pronounce your name wrong. I'm really sorry, but Seon has suggested also D plus E. Is that a plus D minus A? Not quite sure about that one. Can you see why? So we have a suggestion of D plus E plus B minus A. But then this has 2 free plus signs, if you consider the plus sign here, and 1 minus sign. But this one has 2 plus signs and 2 minus signs, so they look a bit different. So it's close, but not quite. Yeah, we have. I'm going to write down the first suggestion. So we have A minus B minus D plus E. We have minus A plus B minus D plus E. And then we have a minus A minus B plus D, which we already have. But thank you again. So A plus B minus D minus C and D plus E minus A minus B are essentially the same because you've just multiplied by -1. So I'm going to cross this one out. And the rest, we have A plus E minus B minus D and E plus B minus A minus D. Well, they're essentially different because they're not multiples of each other. So as before, we know that their product is a factor of star. And then again, considering degrees, because star is a cubic in A, B, D, and E, and then their product will also be a cubic in A, B, D, and E, we know that they differ by a constant multiple. And can someone fix the constant K for me? It's probably a bit hard to see. So how will we fix K? We have a suggestion of -3 plus 12 dE, but that depends on D and E, and we want it to be a constant. Yes, so we want to consider a coefficient of A. Let's consider A cubed. And over here, and yes, that is true. So over here we have A cubed. The coefficient of A cubed is 1 minus 6 plus 8 is 3. And then over here we have 1 times 1 minus 1, which is -1. And therefore we want K to be -3. So consider coefficient of A cubed, K equals -3. Hopefully that makes sense. If not, please say so in the chat and I will try to clarify. Okay, that looks good. So we have the final bit of the question. We're nearly there. Hence, solve the equation x plus 6 cubed minus 6x plus 6. I'm sure you can read it. It's there. I've called it dagger for convenience. You should have a stockpile of things you can call equations like star and dagger, or different types of stars. And then I've rewritten what we had before in a slightly different way. I've pulled out some minus signs and reordered letters, but you can convince yourself that this is the result we just had. So we want to make this look like this. So what are we going to make A, B, C, and A, B, D, and E? That should be a D. Excuse the typo. Any suggestions for, say, A? Yes, precisely. So we want, so let A equals X, because then we have an X plus stuff, and then 6 minus 6x plus stuff, plus x squared plus stuff, etc. And that looks almost like what we want. And then we want the remaining B plus D plus E equals 6. Someone is ahead of me, but let's do this. Plus D squared plus E squared is equal to 14, and then B cubed plus D cubed plus E cubed is equal to 36. So that comes from equating this bit with this bit, this bit, this bit, and of course this bit with this bit. And somebody has already suggested what B, D, and E could be, but I think not everyone is that quick. So, well, firstly, there's 3 equations and 3 variables, so we could try and solve this, say, by substitution, but this is a cubic equation, and we probably don't want to be solving a cubic equation by substitution. It's going to be quite nasty. So usually in STEP, this is not an absolute rule, so be prepared to be thrown off sometimes, but usually in STEP the numbers are nice. So if you can spot a solution, that would be good. And in this case, we have a suggestion of B equals 1, D equals 2, and E equals 3. Does this work? Well, we have 1 plus 2 plus 3 equals 6. We have 1 squared plus 2 squared plus 3 squared is equal to 1 plus 4 plus 9, which is 14. 1 cubed plus 2 cubed plus 3 cubed, that's 1 plus 8 plus 27. That is 9 plus 27, which is 36. Yay. And so we have fixed our B, D, and E. And therefore, what is dagger dagger? If we just plug in our A, B, D, and E. This might be 1 or 2 lines on a scrap piece of paper. So we want to plug in an X here, 1 here, 2 here, and a 3 here. Yep, we have x minus 4. We have a suggestion of x minus 4, x minus 2 times x. Let's see where that comes from. We have, do this on the side, we have a x plus 1 minus 2 minus 3. That was a strange 3. And then we have an x plus a 2 minus a 1 minus a 3. We have an x plus 3 minus 1 minus 2, which I believe is x minus 4, x 2 minus 1 minus 3 is a minus 2, and an x 3 minus 1 minus 2 is a 0. So yeah, we have what we wanted. And so what is the solution? Great. So x is equal to 4, 2, or 0. And that's the step question done. Hooray.